So, our galaxy is constantly moving through space at incredible speed, together with thousands of other galaxies. Weirdly, all of them are drifting in the same direction, pulled by something unbelievably massive that we still can't see directly. We've known about this space mystery for decades, but now astronomers think there may be one more force at play. Now, for a long time, scientists have known the Milky Way isn't standing still. Instead, it's traveling at about 375 miles per second. If you were moving at the same speed, you'd go from New York to Los Angeles in about 10 seconds. And apparently, our home galaxy has a destination in mind. No one can see it directly, but we can observe its effects. We also gave it a name, the Great Attractor. Hey, that was my nickname in high school. No, not really. This enigmatic region is in a part of the sky called the Zone of Avoidance. It's hidden behind the thick disk of the Milky Way. Unfortunately, too many stars, dust, and gas are in the way too, so we just can't look through this thick cloud. It's like trying to see through heavy fog, but this fog is made of stars. So instead of seeing the Great Attractor, scientists had to figure it out from our motion. Back in the 1980s, a group of astronomers nicknamed the Seven Samurai were tracking about 400 galaxies. And they noticed something odd. A lot of those galaxies were all drifting in the same direction. It was like something massive was pulling them in. That something ended up being the Great Attractor, located around 150 to 250 million light-years away. How did we figure it out? Well, at first, astronomers thought we were just moving toward the Virgo cluster, a big group of galaxies nearby. But then they realized that the Virgo cluster was moving too, toward an even larger structure called the Virgo supercluster. And then, in 2014, it turned out that all of that was part of an even bigger structure called the Laniakea. That's a giant region containing around 100,000 galaxies, including the Milky Way. And somewhere near its center is what we now call the Great Attractor, a massive gravitational anomaly, pulling huge numbers of galaxies in the same direction. But even the Great Attractor is not the final boss in this story. When we zoom out even more, things get even bigger. The galaxies near us, and the Great Attractor itself, are all moving towards something even larger, called the Shapley supercluster. It contains more than 8,000 galaxies and has a mass of over 10 million billion suns. It's the most massive galaxy cluster within about a billion light-years of us, and everything in our corner of the universe, including our own galaxy, is slowly drifting toward it. But let's get back to the Great Attractor. Is it actually dangerous for us? Are we going to end up falling into it? Definitely not. Even though it sounds like we're being pulled in, the Milky Way will most likely never actually arrive there. The reason is that the Laniakea supercluster isn't a tightly bound structure. Now, space is expanding all the time, and that expansion keeps stretching distances between galaxy groups. So, while gravity is pulling things together locally, the universe is also pushing everything farther apart on the biggest scales. Right now, gravity is still strong enough that the Milky Way and nearby galaxies are drifting toward that region. But over billions of years, the expansion of space will slowly win. At some point, the pull from the Great Attractor will get too weak compared to how fast space is stretching. The motion won't stop completely, but we won't be able to reach our destination. So instead of a dramatic final collision, we'll just keep moving in that direction for a long time, and we'll never actually arrive. Good news? Well, it would be if scientists hadn't found something that might influence our galaxy even more than the Great Attractor. It happened like this. At one point, astronomers needed a proper map of where galaxies were. For a long time, there was a gap in that map. It looked like something massive was sitting behind the Milky Way, but no one could actually see it. Galaxies nearby were moving in slightly strange ways, like they were being tugged by something big. But the object causing those strange patterns was hidden from our sight. Optical telescopes just couldn't see it. until scientists used the Meerkat radio telescope in South Africa, which doesn't rely on visible light. Instead, it picks up radio waves, especially something called the 21-centimeter hydrogen line. That signal comes from neutral hydrogen gas and passes through dust almost totally unaffected. And suddenly, the hidden part of the universe became much more accessible. Astronomers were especially interested in the Vela supercluster. It's massive, stretching roughly 300 million light-years across and located around 800 million light-years away. We'll get back to the space monster a bit later. First, let's figure out how Meerkat can actually see galaxies sitting behind the Milky Way's disk. You see, each galaxy leaves a clear signature in that hydrogen signal we talked about. If a galaxy is moving away from us, its signal gets stretched out. In other words, it shifts toward lower frequencies. That's called redshift. And because the universe is expanding, that redshift can also tell us the distance. So by measuring it, scientists can figure out where each galaxy sits in 3D space. This helped astronomers detect thousands of previously unseen galaxies. The previous vague, blurry region of space suddenly turned into something very structured. Scientists saw a huge cosmic formation with two dense cores. It means that the Vela supercluster is a real complex structure, and we can finally see its shape. There's another interesting thing. That hydrogen signal doesn't just trace where galaxies are. It also shows us regions of cold, dense gas, the raw material galaxies use to form new stars. So this map also hints at where future star formation is more likely to happen, giving us a rough preview of how the universe might evolve. Now that we've mapped Vela, its size is hard to ignore. That's about 30 million billion solar masses of material. This supercluster is among the most massive structures we know of in the nearby universe. And such big structures act like gravity wells. Galaxies slide toward those regions, forming large flows across huge distances. This affects us directly. We already know that the local group, the Milky Way, Andromeda, and a bunch of smaller galaxies, is moving through space at a breakneck speed compared to the cosmic microwave background. This microwave background is the leftover glow from the Big Bang, which fills the whole universe. Scientists can already explain a lot of that movement using known structures like the Great Attractor. But not everything adds up. And that's where Vela comes in. Its size and location affect how our galaxy moves. So, some of the missing motion we saw starts to make sense when we add Vela in. It can help clear up a gap in our models of how the universe moves. At the same time, Vela shows that our map of the universe is still incomplete. For a long time, astronomers treated the zone of avoidance like a blank region. Not super important, just hard to look through. But now, it turns out that hidden regions can have structures just as large as the ones we already know about. So, a pretty obvious question is, if something this big stayed hidden for so long, what else is still out there? We might find out pretty soon. Meerkat is already one of the most sensitive radio telescopes we have for the southern sky. And the next step is the Square Kilometer Array. This one will be able to pick up fainter galaxies and trace the thin cosmic filaments that connect everything to a ginormous cosmic web. Right now, Meerkat has basically revealed the core of Vela. SKA could show how it spreads outward, forming part of a much larger cosmic network.